Good evening everyone, it's 13th of December 2025, Saturday, 9 p.m. here. In this video, I'll be talking about the difference between luminance and illuminance because I want to correlate these terms with retinal luminance and retinal illuminance, and why we should know about it because the background luminance of visual acuity chart it needs to be standardized, and it is to facilitate the comparison of visual data across different countries for research purposes. So to ease that comparison and to allow that comparison to happen, it's very important to standardize the visual acuity or chart background luminance. Visual acuity depends upon the luminance of background chart, the contrast between the target letters or symbols or numbers versus the background luminance. It's very important to standardize it because if it is brighter, for certain limit it can be constant, but beyond certain limit it can decrease the visual acuity because of the glare, and if it is too low then it might not activate or let the cones operate and rods predominate, and then it's like a dark adaptation, and in dark adaptation the visual acuity is less because of the large receptive field. Rods correspond to the large receptive field. Large retinal receptive field means many rods converging, many photoreceptors converging onto a single ganglionic cell, and if it is so, the retinal sensitivity to light increases, and that's why you see the rods are acting and they are converging on a single retinal cell, many, and that's why we can perceive things in darkness because of these rods and large receptive field. But the visual acuity is less because resolution is less as rods are widely spaced, so it's going to affect the resolution and decrease the visual acuity. The mark, that is minimum angle of resolution, will be more, and that will cause decrease in the visual acuity. And as long as light adopted state is photopic vision is concerned, the cones, they correspond to small receptive field, especially in the foveal region it is 1:1, 1:1 ratio for cones, bipolar cells and ganglionic cells. So it's a very good thing for visual acuity and resolution. It betters the visual acuity and even the resolution, and the cones there are densely packed. That's why minimal angle of resolution becomes smaller, and the resolution is better, visual acuity is better in the central part, and in the central part cones dominate and they operate in light, and that's why we see better in light adopted state to a certain range, because if it is beyond certain range, it crosses certain range, then because of the glare the visual acuity gets reduced. So coming to what is luminance and what is illuminance, because I got confused why, like, sometimes the books are mentioning the word luminance, retinal luminance, and then retinal illuminance. So what's the difference? The difference is luminance is the light intensity that is reflected from the light, amount of the light that is reflected from the source or the surface per unit area of its surface. Like suppose the light is coming from this bulb or this tube light in a specific direction, that is, it is directed towards me, that area per unit area, how much amount of the light that it is reflecting towards me, towards the observer, and that in a particular direction, and that amount of light per unit area of that source or reflecting surface, it is called as luminance, and it is measured in nit or candela per meter square. Now candela, we have already learned that candela, because light intensity or the amount of the light was compared, the brightness was compared with the candle, and it is still the same, but it is more specified because candles can be of different size, so it is more specified these days for comparison to measure the light in a more specific way. So it was about candela per meter square. The luminance unit is candela per meter square. It is just amount of the light that is reflected off the light source or any surface that is reflecting the light towards the observer in a specific direction. So that surface area is of the light source or the surface area that is reflecting the light towards an observer. It is not the surface area of observer, eye surface area of an observer. No, it's not like that. Surface area of source or surface area of reflecting surface, that is luminance, and it is nit, 1 nit NIT equals to 1 candela per unit area per meter square. 1 candela per meter square is 1 nit, and nit, it comes from the Latin word nitere or niter. It means to shine or to glitter. So that was about the luminance. Now coming to illuminance. What is illuminance? Illuminance, it is just the amount of the light falling on surface area per unit surface area, be it any, whether it's reflecting the light or not, it's not the case. It's just the amount of the light that is falling per unit area, that is illuminance. Now this luminance, that is amount of the light that is reflected off the surface area per unit area, or the amount of the light coming from the source from per unit surface area of the source or any reflecting surface, that is luminance. And more the amount of the light per unit area, obviously coming towards the observer will perceive that surface or that source or object that is reflecting the light per unit its surface area. If it is more, then we'll perceive it as a brighter object or brighter source or brighter reflecting surface. So it is a measure of potential of brightness of an object, be it reflecting surface, be it a source, be it an object that is reflecting the light. So that was about the luminance. And illuminance, it just, we are not seeing it, it's just light that is falling. We are not caring how much light is reflecting off the surface. It is just the amount of the light falling on surface area per unit area. Okay, any surface area, be it floor, be it wall, be it cupboard, be it anything, be it a wooden plate, anything, be it amount of the light falling on my hand, falling on my retina per unit area. So that is illuminance. So what is retinal luminance and retinal illuminance with respect to these definitions? Retinal, amount of the light that is reflected off the retina per unit area of the retina, means retina, suppose some light falls on the retina, because retina is not self-illuminating. So suppose some light is falling on the retina, and the amount of the light now the retina is reflecting off its surface area per unit area, that is called as luminance, and that is directed towards some observer, for example retinoscopy and all that we do. So we see what we see the retinal luminance, because we are seeing the light that is coming from the retina to us, and where it is measured in candela per meter square is amount of the light coming from the retina to the observer's eye, for example doctor or optometrist. It's coming to our eye, but it's called as luminance when it is the surface area of the retina. How much surface area per unit surface area of the retina that is reflecting the light towards the observer in a specific direction, that is retinal luminance. And what is retinal illuminance? It is the amount of that bulb, amount of the light from a bulb that is falling on the retinal area per unit retinal area, that is called as retinal illuminance. Light falling on the retina per unit area of the retina falling from the bulb, that is called as bulb or sun, that is called as retinal illuminance. And retinal luminance means it is the brightness of the retina. Now the retina is not, bright, like it is not a source of light. It doesn't have light on its own, like some, it can reflect the light, but it doesn't have the light. It cannot create its light. So for example, if there is a dark, you cannot see the retina, but there should be source of light, and then it will just hit the retinal surface, then light will be reflected and we can see the retina. Now the amount of the light reaching the retina per unit area of the retina, the light falling on per unit area of the retina, it is called as retinal illuminance. And the amount of the light that is reflected off the retina per unit area of the retina, that is called as retinal luminance. How much bright the retina will appear to a doctor or optometrist of a patient. I hope this concept is cleared. Now examples are computer screen. For example, amount of the light that is coming from the computer, so it is 300 nit, that is, yeah, candela per meter square, and it is the amount of the light from a per unit surface area of the laptop screen, so that is 300 nit. And if it is more, then we will see, if it is 500 it will look brighter, if it is 300 200 it will be like normal computer that we see, and if it is less than that, even less than 100 nit, then it will appear little bit darker, less bright. Overcast sky luminance is 1000 nit, that is equivalent to log 3. So why we should know? Because the background luminance of the visual acuity testing charts, this luminance needs to be standardized, and it is to facilitate the visual acuity data in different studies, to compare them, to facilitate their comparison across various countries. Various countries will have their own data, different races and different diseases from different cities, different countries, their genetic makeup, and so we should be able to compare. We should have some common base to compare these things. So we want the common, we want the stable and constant luminance of visual acuity chart, background luminance of the visual acuity chart. And many communities, many societies, they try to standardize it, because everyone wants to have their own opinion, and they want everyone to follow their wishes and desires. So there are so many councils, and they recommend their own background luminance for visual acuity testing charts. So according to National Academy of Sciences, National Research Council of United States, they recommend 85 nit. Log L is 1.9, equivalent to 1.9 log L, 85 nit, but it's not followed everywhere, and it is not universally followed, because other committees are there, they have their own recommendations. So, and it also recommends visual acuity testing room. It also recommends that the room should not be too lit or too dim. Ambient light should be there, and that ambient light should be compared with the background luminance, and that ambient light of the room should not be more than 1.5 times brighter than the background luminance of the visual acuity chart. In the past, during the ETDRS study, 200 nit background luminance was used for visual acuity chart testing. Now Germany, they use 300 nit background luminance for visual acuity charts. Then United Kingdom, it uses 120 nit, 120 around 200 log 2, 100 log 2. Then International Council of Ophthalmology, they recommend 160 nit. So NAS and RC, American United States, they recommend 85 nit. Then ETDR study in the past 200 nit was used. Germany 300 nit, UK 120 nit, International Council of Ophthalmology ICO they recommend 160 nit. So yeah, if the background luminance of the visual acuity chart is more, then visual acuity will be better to certain extent, and beyond certain point the brightness is too much. If it is too much, then it will cause glare and it will cause decrease in the visual acuity. Then if it is less, then obviously, and also it background illuminance and the target background luminance and target luminance and their colors, their shades, they form the contrast. And if it is more, then visual acuity will be more, and that's why it's very important to standardize this background luminance. And how the retinal illuminance is calculated. Now it's very difficult to calculate the retinal surface area. So what this scientist did, known as Leonard T. Troland, what he did, he used pupillary area to measure the retinal illuminance. It's very difficult to measure the retinal area, surface area clinically. So to measure the retinal illuminance, that is the light falling on the surface area of the retina, per unit surface area of the retina, rather than using per unit surface area of the retina, he used the pupillary area. Common sense. He used pupillary area, how much it is dilated, and we know that it's circle, so it's like pi r square. And surface area is pi r square. R is the radius. If suppose if it is we say it is pharmacologically dilated 6 mm, so it is diameter, 6 mm is diameter of the pupil, it becomes diameter, and radius becomes 3 mm. Now what is, according to Leonard T. Troland, he suggested, recommended this, or invented, discovered this unit, Troland, his surname maybe, Leonard T. Troland, yeah, his last name. So 1 Troland means eye chart luminance in it into pupillary area per millimeter square, pi r square. For example, suppose if the background luminance of visual acuity chart it is 100, then 100 into 3.14 pi into r. If the pupil diameter is 2 mm, then radius becomes 1, then it becomes 314 Troland, like that. If it is 160 if it is 85 nit, then background luminance, if it is 85, then 85 into 3.14 into 1 square. If the pupil diameter is 2, then radius becomes 1, then it comes the value in Troland comes to be 266.9. So what's the significance of this Troland? See, human visual system, it reaches photopic operation at around 100 Troland. So background luminance should be 100, because we want to measure the photopic vision. We are not interested in measuring the scotopic vision. For standardization, we measure the photopic vision, and hence the background luminance of the visual acuity chart, and even the room illumination should be more than what? It should be more than 100 nit. So background luminance should be more than 100, background luminance should be more than, it should be such that the Troland becomes 100. Yeah, so if 85 is 266, then yeah, almost 85 into 3 times, so around 30 nit, 35, 30 nit, it's the threshold for it to be 100 Troland. For 2 mm pupillary area. So yeah, so that was about the TROLAND, Troland, that is the unit of the retinal illuminance. So retinal illuminance unit becomes Troland, and retinal luminance unit is candela per meter square, or nit. So human visual system reaches photopic operation when retinal illuminance is 100 Troland. So we want that, we want the photopic vision, we want to taste the photopic visual acuity, and that's why we standardize the background luminance of the visual acuity chart. Also, the room light should be lit enough, not too dim, not too bright. It should be not more than 1.5 times brighter than the background luminance of the visual acuity chart for the human visual system to operate at photopic vision. So that was all about the luminance and illuminance and retinal illuminance versus, and application of it on the human eye, and retinal luminance, retinal illuminance, and background luminance of visual acuity charts. So I hope you understood why I taught you about this luminance and illuminance. I had to go through so many things because I was not getting what is the surface area, candela per meter square, and again the light falling on the surface, it's like per meter square. Again it is like per meter square. So what area exactly? For luminance, it is the surface area of an object or a source of light or a surface that is emitting the light. If it is emitting more light per unit area, it will appear brighter to an observer. So it is directed towards an observer, and that's why it is luminance, because it has a specific direction. And illuminance, it is nothing but just amount of light that is falling per unit area of any object, be it my hand, be it my retina, be it my hand also. See, my hand also is, if the amount of the light falling on my hand, or amount of the light coming from this bulb tube light on my retina per unit area of the retina, that is retinal illuminance, or per unit area of my hand, that is my hand illuminance. And the amount of the light that is reflected off my per unit area of my hand towards you all, that is called as luminance of my hand. And luminance of my retina, it is used for my retinoscopy, like amount of the light that is reflected off my retina per unit area of my retina, directed towards observer, that is optometrist or doctor, that is called as, that amount of light per unit area of the retina reflected off the retina, that is called as retinal luminance. Hand luminance, retinal luminance, and hand illuminance and retinal illuminance. I hope you got these concepts. It's very, very important. It is just I found it interesting, so I decided to share this out. So remember, what's the difference between luminance, illuminance? Their units: nit, candela per meter square. Why the candela name? Then what's the unit of the retinal illuminance? 1 troland and 100 troland. It's very important because we cannot it is measured with pupil area, because we cannot measure the retinal area like in a human being as such clinically. To ease that, he took this pupillary area to measure the retinal illuminance, that is amount of the light falling onto the retina, not coming off the retina per unit area. It is falling on the retina, that is retinal illuminance. And how much amount of the light should fall onto the retina? It is 100 troland for human visual system to operate at photopic vision. So that was all. I hope you understood it. I tried my best to explain these things to you. Bye. Good night. Enough for today. Tomorrow I'll be talking on Stiles-Crawford effect. I would like to make videos on topics which are not available on YouTube nicely. Like there are topics which talk about luminance and illuminance, but they don't talk about retinal luminance and retinal illuminance and their significance for ophthalmologists, like in our field. So that's why I'm making these videos, because they are not available, and I really enjoy because people should we should help people, and helping people means we should help ourselves. Like if I have to teach you, I have to teach myself first, understand things myself first, and if I share my knowledge with so many people, it helps me to understand things even better, deeper, and memorize things. And it's a joy to share things. It's a kind of expansion, and expansion is beautiful process, like positive expansion, about good things, noble things. So yeah, even Styles Crawford effect, the video on it is not there on YouTube, so I decided it, like I literally gave that topic hours and hours. Literally 2 days I have given 8 to 10 hours just to understand Styles Crawford effect. I have read so many books, so many chapters, and so many articles. And tomorrow I'll be making a short video on it, not more than 30 minutes, on Styles Crawford effect, maybe 15-20 minutes. So because it was very difficult for me to understand, but I came across one article and it was like boom, enlightenment, and I got what actually Styles Crawford effect is. And I got it because I understood the process, like how it was discovered by Styles and Crawford. Yeah, and that's how I got it. Once I know how the phenomenon happened, how it was discovered, then it's very easy for me to understand the concept. So tomorrow I'll talk on Styles Crawford effect. Enough for today. Bye. Good night.